Grade 12s, welcome to Calculus, and we're going to start with a review of PreCalculus. Now, this is usually something I do over 5 days, and if you look at my website, you can actually find all 5 videos, because I'm going to fly through this. I just want to give you a sense of some of the things you were supposed to know for this course, but I know for some of you it's been a long time since you took math, and you might not remember all this stuff. So don't freak out. Hopefully some of these things you remember, and if there's other things you don't, you know the sort of things that you want to get a little extra help with in the first few weeks of the course. But these are definitely things that are going to come up over and over and over in the course. You got to get these things down. Okay, so the first one, very important. I'm sure you remember some of this, which is factoring. So there's different types of factoring, and remember, the first type of factoring you always want to try to do. You won't always be able to do it, but you want to try to take out a greatest common factor. And there is a greatest common factor in this first question. It's 2. So we take out a 2, and we're left with x to the 4th minus x squared minus 12. Now, this, we're not going to lose the greatest common factor. We're going to leave that up front. This is actually a trinomial that we can break into 2 binomials. And often this will be the case when it's x squared here, right? And you have x and x. Well, this is exactly the same thing, except it's x to the 4th. So it's not going to be x and x, it's going to be x squared and x squared. Those two things multiply together give you the x to the 4th. Alright, anyway, so now we do our thing where we look for 2 numbers that multiply to this number. They have to multiply to 12 and add to -1. It's actually multiply to -12 and add to -1. Or if you've been in my class before, the way I think of it is 2 numbers that multiply to 12 and subtract to 1. And it's 4 and 3. So I have x squared minus 4. I drag down that sign. Again, I'm using some tricks here. And x squared plus 3. You might not know my tricks, but you should know how to do this. Now, look, you can still factor this one right here. This first bracket right here is a difference of squares. So you have the 2 up front, which was the greatest common factor. X squared minus 4 can be factored into x plus 2 and x minus 2. Remember, x times x is x squared, 2 times 2 is 4, and then you put different signs. One has to be plus and one has to be minus. Plus, we still have the x squared plus 3. And that's it. Okay, how about this? There's no greatest common factor. We have this number up front. Oh, this is one of the ones I call Bobby Bridge, right? You got to multiply the 8 and the 3 and get 24. Or if you want, 8 and 3 and negative 24. But anyway, I'm looking for 2 numbers that multiply to 24 and subtract to 10. Multiply 24 and subtract to 10, that's 12 and 2. So this is decomposition, right? I keep the first one the same. My numbers are 12 and 2, so I'm going to decompose the 10x into 12 and 2. How would I do that? I'd go plus 12x and take away 2x minus 3. And now, once you've decomposed it, you pair them up. You look at the first pair and take out the greatest common factor, and you look at the second pair and take out the greatest common factor. First pair, it's 4x. What's left? Well, 4x times 2x equals x squared, 8x squared, and 4x times 3 equals 12x. And this one, the greatest common factor is just 1. Include the negative. Since the first term's negative, put -1. -1 times 2x equals -2x, and -1 times positive 3 equals -3. Hey, I'm pretty confident I did it right, because I have 2x plus 3 in both those brackets. So I take that out as a greatest common factor, and I'm left with 4x minus 1. And that is the answer. Okay, next one, there is a greatest common factor. You might think it's 5, but again, if the first term's negative, take out a negative as well. So I'm going to take out -5. -5 times positive 4x squared equals -20x squared, and -5 times -1 is positive 5. Oh, look at this part in brackets. It's a difference of squares again, just like we did up here. So, what multiplies by itself to get 4x squared? 2x and 2x. What multiplies by itself to get 1? 1 and 1. Make one of the binomials positive, make the other one negative, and you're done. Okay, what if we start with 4 terms? What do you do here? Well, this is just like when we had the 4 terms here and I underlined the first 2 and the second 2. We're doing exactly the same thing. We're just going to pair them up and hope we get the same thing in the brackets. And I'm pretty sure it'll work here. So in the first pair, x is the greatest common factor. I'm left with 2x plus 5. In the second pair, I'm just going to have to put 1, or because it's negative, -1, and that leaves us with 2x plus 5. Remember, -1 times positive 5 equals -5. It worked. We got 2x plus 5 in each one, and write x minus 1 in the second one. Okay, that's a review of factoring for you. Solving equations, these are all quadratics. You're going to solve lots of quadratics in this course. Basically with quadratic equations, you want it to be equal to 0, and then guess what you do? You factor. You're just going to have more factoring practice here. So look on the left hand side, you can take out an x as a greatest common factor, and you're left with x minus 5 equals 0. Now, you're multiplying two things and it equals 0. Remember the zero product property? It means either this is 0, in other words x is 0, or x minus 5 has to be equal to 0. And if x minus 5 is equal to 0, then x is equal to 5. Those are your two answers in this case. This one, yes, you could expand this out. X minus 5 squared, you could expand it. But you can also do this by using square roots. You can move the 50 over, so you get x minus 5 squared is equal to positive 50. And now we're going to do the opposite of squaring. We're going to square root both sides. Now, when you square root here, you just have x minus 5, because squaring and square roots are opposite, and they undo each other, so to speak. But on this side, remember, you need to put plus or minus. When you solve equations and take a square root, you got to put plus minus. So you have plus or minus root 50. But wait a minute, root 50, we're not too happy with that. We're going to change that in a second. Let's move the 5 over, so negative 5, it moves over, becomes 5. And we have plus or minus, now 50. Let's write that as simplest radical. You know how to do that? Think of the perfect squares. 50 is the same as 25 times 2. So rather than taking the square root of 50, take the square root of this. And you can take the square root of 25. The square root of 25 is 5, but you can't take the square root of 2, so that stays inside. And that's what we've got right here. So this is a great answer. The other thing you could do if you wanted to is you could factor out a 5 from both terms. So you'd have 5 and then 1 plus or minus root 2. Either one of those work for me. Okay, this one you do have to expand. So we're going to use the distributive property here, get 2x squared plus 2x, and on this side there's nothing we can do. And remember, with quadratics you want everything to one side, so it equals 0. Keep your x squareds positive. So I'll keep this here, move the 7x over, so this will become negative 5x, and move the negative 2 over, and it becomes plus 2. And then we factor if we can. And we can in this case. It's Bobby Bridge. You got to multiply these two together and get 4. Two numbers that multiply to 4 and add to 5, it's 4 and 1. So you're going to have 2x squared minus 4x minus 1x. We've decomposed that 5x into 4 and 1. Plus 2 equals 0. And we pair them up. You can take a 2x out of the first pair, and you're left with x minus 2. Take out a negative 1 in the other one, you're left with x minus 2. Still equals 0. So look, we have x minus 2 in both cases. So we've got x minus 2 times 2x minus 1 equals 0. This one's easy. What would make x equal 0 here if x is equal to 2? This one's a little bit harder, but I bet by now you know how to do this in your head. X is equal to 1/2 there, right? You could move the 1 over to the other side, becomes positive 1, then divide by 2. Again, I'm going super fast here. It's just to kind of remind you of these things. Hoping some of them you remember and others you ask me for extra help. Last one here, you need to make sure it's equal to 0, so move the 8 over. X squared minus 4x minus 8 equals 0, and then we factor. Two numbers that multiply to 8 and subtract to 4. Uh-oh, can't do it. What do I do? X equals negative b plus or minus square root. If you've been in my class, you know the song. B squared minus 4ac divided by 2a. Okay, so we're going to plug everything into here. So what's that look like? Well, our a value is 1, our b value is negative 4, and our c value is negative 8. So x equals negative b, that'd be negative negative 4, which is positive 4, plus or minus. B squared, that's negative 4 all squared, which becomes positive 16, minus 4 times a, which is 1, times negative 8. So it's going to be negative 32. Let's save a step, and I'm going to write negative 32 in here. So it's minus negative 32 all over 2a, that's 2 times 1, which is just 2. X equals 4 plus or minus 16 take away negative 32 is the same as 16 plus 32, so you get 48 all over 2. Now we've got to simplify that radical. So let's see, 48 is the same as 16 times 3, and I can take the square root of 16. It's 4. So the 4 comes out, and the 3 stays in. Divide it by 2. As long as you can divide both of these terms by 2, you can do it. So 4 divided by 2 is 2, plus or minus 4 divided by 2 is 2. And that's your answer. Okay, here's one thing that you probably have not learned before, or if you have, you haven't used it too much. You will have to use it from time to time, not a lot to tell the truth. This is probably the one thing that you won't use a lot in calculus. Difference of cubes and sum of cubes. So we talked about difference of squares. That would be like the highlighted part right here, right? Difference of squares, x plus 2, x minus 2. And you've learned that you can't do a sum of squares. You can't factor a sum of squares. But you can factor a sum of cubes. And you can also factor difference of cubes. So I'll give you a formula, which I always forget, to be honest. Okay, so here we go for difference of cubes. It'd be a cubed minus b cubed. That's the difference of cubes, right? Difference means take away, and these are both cubes. It equals a minus b, and you're going to multiply that by a squared plus ab plus b squared. For sum of cubes, so that would be a cubed plus b cubed, you can factor that into a plus b times a squared minus ab plus b squared. So let's see how it works. In this first one here, we obviously have a difference of cubes. Now, what's a and what's b? Right? What is the piece that's being cubed in this bit here, in that first term? What's being cubed? Well, a is equal to x y squared. Does that make sense? If you cubed xy squared, what would you get? You'd get x cubed y 6. Okay, yeah, that works. For b, what's being cubed to get 64? 4 is cubed to get 64. So here's what your a is, here's what your b is. You just plug it into this formula and you'll be done. So it says a minus b. Well, that's x y squared minus 4. And then a squared, so that's x y squared all squared plus ab, that's x y squared times 4 plus b squared, so that's 4 squared. Now we just simplify. Nothing we can do in the first one. Second one, x y squared squared. I'm going to spread the love here, people. X squared and y to the 4th plus 4xy squared, and 4 squared is 16. And you factored it. Okay, similarly for this one, what's the a, what's the b in this one? Well, the b is pretty easy. It's 1. 1 cubed is 1. What do you cube to get 27x cubed? You cubed 3x. And there you go. Now you plug that into this formula and you'll have this one as well. So let's try it. A plus b, that's 3x plus 1. Okay, let's see if we can do this in one step. A squared, so that's 3x all squared, right? So that's 9x squared. Minus ab, well that's just 1 times 3x, so it's just 3x. And then b squared, 1 times 1 is 1. I've factored it. Okay, sorry how long this video is going to be. Rationalizing expressions. So, you've done this before. We usually rationalize the denominators. Remember how to do that? First of all, if it was just one term, like 5 over root 3, remember what you do? You multiply the bottom by root 3, you multiply the top by root 3. So then, 5 root 3 on the top, and root 3 times root 3 is 3. Look, no more radical on the bottom. So that's if it's just a monomial. Remember what to do when it's a binomial? You multiply by the conjugate. So we multiply this by 2 plus root 7. You change the sign in the middle. And what you do at the bottom, you got to do the top. Okay, so now on the top, we have a binomial times a binomial. So we go 1 times 2 is 2. 1 times root 7 is root 7. And 2 times root 7 is 2 root 7. So you put those together and you get 3 root 7. Root 7 times root 7 is 7. On the bottom, you've got 2 times 2 is 4. 2 times root 7 is positive root 7. And 2 times negative root 7 is negative 2 root 7. They cancel out. This is going to happen every time when you rationalize the denominator, is that the radicals should cancel out. Otherwise, you've done it wrong. And then you have negative root 7 times positive root 7, so it's going to be negative. And root 7 times root 7 is 7. Simplifying time, 2 plus 7 is 9 plus 3 root 7. And on the bottom, we have 4 minus 7 is negative 3. Again, if you can divide both terms by the denominator, you're allowed to do it. So 9 divided by negative 3 is negative 3. And 3 divided by negative 3 is negative 1, but we don't even need to put the 1. Still have the root 7. Okay, now this looks weird. There's no denominator. Well, guess what you have to do sometimes in calculus? You have to rationalize the numerator. It's no more difficult. You'll see very early in the course why we have to do this sometimes. I won't get into it today. So, you know what you'd multiply this by to rationalize it? The conjugate would be root x plus 2 plus, I'm changing that sign, root x plus 1. And what I do to the top, I got to do the bottom. So I'm going to do exactly the same thing. Okay, so we got to multiply this times this. Root x plus 2 times another root x plus 2 equals x plus 2. Now, I got to multiply this times this. I'm going to get some positive amount, root x plus 2, x plus 1. And then I'm going to multiply these two together. I'm going to get negative x plus 2, root x plus 2, x plus 1. It's exactly the same thing, but negative. They're going to cancel out. That's always going to happen, remember. The two middle terms will cancel out when you rationalize the denominator. What we still need to multiply is this negative root x plus 1 times positive root x plus 1. Well, negative times a positive is a negative. I'm actually going to put this in brackets. And you get, when you do root x plus 1 times another root x plus 1, you get x plus 1. Must put it in brackets or you'll get it wrong. All over. Well, there's nothing to do here. Just rewrite it again. You get 1 times all this, so it just stays the same. Root x plus 2 plus root x plus 1. Anything we can do on top? Yeah, there is. We have x, take away x. Oh, our x's just cancel. And then we have 2, take away 1, which is just 1. So we end up with 1 over the whole denominator. Root x plus 2 plus root x plus 1. Again, seems weird to end up with radicals in the denominator, but you'll see when we're talking about limits, sometimes it's important to do that. Okay, next, you're going to write a lot of equations in this course, and they're always going to be in general form in your textbook. I don't know why they love general form. I personally hate it, but we want to be able to check our answers. So here's general form. ax plus by plus c is equal to 0. So it's always going to be equal to 0. Here's the thing. No fractions. No decimals. For the a, b, and c, they've got to be integers. Except for one other thing. A has to be positive. Can't have that be negative. First question. We want to get the equation of a line that's perpendicular to this line and passes through this point. So let's look at this line here first of all. This is in slope-intercept form. Perfect. There's our slope right there, right? 1/3. Now if there's a line that's perpendicular to this one, what would the slope be? Remember what's the case about perpendicular lines? The slopes are negative reciprocals. You take the reciprocal, which is just 3, and make it negative. So you'd have negative 3. This is your slope for the line you're interested in. And the point you're interested in is right here, 4, negative 2. So how do we do this? Use point slope form. Point slope form looks like this. Okay, well you know what goes in the m spot? That's negative 3. Y just goes there, and x just goes here. And then what you do is you plug these values into the y and the x1 and the y1. So x1 is 4, so you're going to have x minus 4. I know it's a positive 4 here, but look, it's take away whatever x is, so it's minus 4. And it's going to be y plus 2. Why is it plus 2? Because it's y take away whatever y1 is, and y1 is negative 2. Y take away negative 2 is the same as y plus 2. Okay, so what could we do next? How about this? Let's do the distributive property here and move the plus 2 over to the other side. We'll do 2 steps at once. So y equals negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. And move the 2 over, it becomes negative 2. In other words, we have y equals negative 3x plus 10. Here's slope-intercept. I wish you could stop there, but because of our silly workbook, our textbook, we need it to be in general form. Well, we're in luck. There's no fractions here. All you have to do is move everything to the left. Don't move the y over here, otherwise your x's will be negative, your a will be negative, and a is not allowed to be negative. A has to be positive. So move these two terms to the left. So negative 3x moves over, becomes positive 3x. We already have our y there, and our positive 10 comes over and becomes negative 10. Don't forget, it's now equal to 0. That's general form. Okay, another one, we've got a line that goes through negative 1, 3, and it also has an x-intercept of 6. Okay, well we can write a point, right? If it has an x-intercept of 6, what's the point? It would be 6, comma, 0. What if it said y-intercept of 6? Then we'd write 0, comma, 6. So we have 2 points. how can we use this now? We can find the slope. Remember, slope is change in y divided by change of x. So let's get our change in y. Change of y would be 3 minus 0, and then negative 1 minus 6. So that's 3 over negative 7, or negative 3 over 7, basically. All right, let's now put it in point-slope form like we did up here. You can use either point, but this one's going to be nice because we got that 0 there. It's always helpful when we have a 0. So I'm going to go y minus whatever the y value is of this point, and it's 0. So y minus 0 is just y, so we're good there, equals m, the slope, negative 3 over 7. Darn it, fractions. And then x minus whatever the x value is, it's 6. Okay, so let's do the distributive property. We get negative 3 over 7x plus 3 times 6 is 18 over 7. Beautiful in slope-intercept form, but we want it to be in general form. So we got to get rid of these fractions. How do we do that? Look at the denominators and get the lowest common denominator, which is 7. Multiply everything by 7. So in this term here, the 7's will cancel. And in this term here, the 7's will cancel. It's only this one you actually need to multiply. So you will get 7y equals negative 3x plus 18, and then again move everything to the left. So you get 3x plus 7y minus 18 equals 0. Okay, finally some functions. State the domain. Remember, domain's the x values. So you ask yourself, what's the lowest x value? Lowest x value is this point, which has an x value of 1. What's the highest x value? 5. So it goes from 1 to 5. So I bet how most of you write it is like this. I love it. That's the way I like to write it. Guess what? Your textbook doesn't do that, I don't think. They write it the other way. Remember how to do that? 1 and 5, you write again. Since we're talking about domain, you put an x in the middle. And then you say less than or equal to, less than or equal to. 1 is less than or equal to x, which is less than or equal to 5. So I'll accept either on quizzes and tests and stuff like that, but I think your textbook gives it this way. State the range. Well, this time we're looking up and down. We're looking at y values. Got to start with the lowest one. Lowest point is at 0. Highest one is up here and here. Both of them are at 3. By the way, let's just pretend that there's an open circle here. Instead of a solid circle, it's an open circle. What's that mean? It means the function goes all the way up to, but doesn't reach this point right here. So in that case, you would use the same numbers, but you wouldn't put a square bracket. Remember, you'd put a circular bracket. Just to remind you there. If I get rid of there, it's a closed bracket. So you're again going to put a square bracket for the 0 and a square bracket for the 3. Or the way you would write it, 0 and 3. We're talking about range, which is y, and you'll always put them in this direction, as long as you go from small to big. Okay, evaluate the function, this function right here, for the following values of x. So if our x value is 2, right, you go over to 2, which point on this function here has an x value of 2? Well, that'd be that point, right? If I go over to 2 and straight up, it's that point right there. What's the y value of that point? 2. Oh, that's my answer. F3. So I go over to 3 as my x, and I go up. That's the point that has an x value of 3. What's its y value? Also 3. F5. So that means my input, or my x value, is 5. Oh, that's right here. This one has an x value of 5. What's the y value of that one? 0. And finally, what if you're given a function and they want you to substitute into the function? So here we go. F of negative 3. What does that mean? That means in the function, wherever you see x, you're going to put negative 3. Now, I recommend when you substitute in, you always substitute in brackets. So I would put 2, and then there's my x. I'm going to substitute negative 3 into it. So in brackets, I'm going to put negative 3 squared minus, in brackets, I'm going to put negative 3 plus 2. You must do this first. Negative 3, it's in brackets. That means you have to square the negative as well. This is equal to positive 9 times 2 is 18. Take away negative means plus 3 plus 2, so you get 23. And then this, I know this seems kind of weird or whatever. This is super common in calculus at the start of the course. What does this mean? This means wherever you see x in the function, you're going to put x plus 2. So I'm going to write this function right here. I'm going to put 2, and then I see x. So in brackets, I'm going to put x plus 2, and it's squared, minus, there's an x again. What am I putting there? X plus 2, and then there's a plus 2. And now we'll simplify. Make sure you square it first. So it's going to be x squared plus 4x plus 4. This minus refers to both things here, so minus x and minus 2, and then plus 2. Distributive property, 2x squared plus 8x plus 8 minus x minus 2 plus 2. Oh, look at that, minus 2 plus 2. Bye-bye. I've got 2x squared. I've got 8x take away 1x, which is plus 7x, and I've got a plus 8. Alright, there you go. There's a quick review, although it wasn't quick, this was a long video. I'm sorry how fast it was. You're probably super overwhelmed and thinking I better go drop calculus right now. It's going to be fine, but these are the things you need to know to get started in the course. Okay, bye-bye.